Alright, so if the natural log of x equals the definite integral from 1 to x of 1 over t dt, the question is, what is the derivative of natural log of x? So if we take the derivative of both sides here, we end up dealing with something we've talked about recently with the fundamental theorem of calculus. On this right side, we can take the derivative of a definite integral from a constant to x. All we have to do, basically the shortcut, is putting x in for this variable, and the integral gets canceled out by the derivative. So we end up with 1 over x. And that's it. Remember, if it were like from 1 to x squared, we'd put x squared in there and then have to multiply by the derivative of x squared. But since it's just x, all we basically have to do is put that in, because technically the derivative of x is 1. So even if we went through that process, we just end up with 1 over x. So derivative of natural log of x is 1 over x. Let's think back to the beginning of our notes. If the derivative of natural log of x is 1 over x, what's the antiderivative of 1 over x? Natural log of x plus c, right? Just going backwards from what we talked about down here. We'll focus on the antiderivatives tomorrow. Today we're going to focus on the derivatives. So if we look down here, we're going to skip that part about the graphs. Here we have the derivative of natural log of u. Have it set up this way because most of the times it's not just going to be a natural log of x. It's going to be natural log of something in terms of x. So when that happens, to take the derivative of that, we're just going to do 1 over whatever we're taking the natural log of, so 1 over u. But we have to use the chain rule. If this is in terms of x, we have to multiply by the derivative of that in terms of x. Right, so it's 1 over u times du dx, or 1 over u times the derivative of u with respect to x. Now sometimes you'll see problems where it has natural log of absolute value of u. Reason for that is, remember, u, or whatever we're taking the natural log of, has to be greater than 0. It can't be negative. So to make sure that's true, a lot of times we may have to put an absolute value on there for a function that could be negative. But the derivative, still the same. It doesn't change. It's 1 over u times du dx.